Let's start with their example. I've opened up the Superstore data, so I'm over here. And you want to create, if you want to look at sales, create the calculated field. There it is. Profit margin, sum of profit divided by sum of sales, profit over revenue. And you can drag that up here instead of sales if you want. And now you could do it by category or subcategory and category. Both. You could do it by both. And try category for colors. Maybe subcategory for colors. Anyway, that's how that one works. Now let's go back to the movie data. This is a fun data set. I mentioned we have the inflation adjusted and the non-inflation adjusted. As long as we have two things that match, we have the U.S. box office non-adjusted, so that's the actual nominal dollars, and the U.S. box office inflation adjusted dollars. So without even looking up the years, assuming those numbers are accurate, I can create an inflation factor calculation. I can take the U.S. box inflation adjusted, U.S. box office adjusted, divide by the U.S. box office non-adjusted. You get that. Let's go back and look at the data. So we created this inflation factor. So Gone with the Wind, it says if this is the accurate number for a non-inflation adjustment, then I have to multiply by 8.3 to get the inflation adjusted. Logically, that means any other non-inflation adjusted value that I have, such as the budget or the world box office, I can multiply by 8.3 and get the box office, the inflation adjusted, which I'm going to do. So I have the inflation factor, I've got the budget, I've got U.S. box both, I want budget both now. And I'll show you why this matters. So this now is going to be the budget adjusted. So I take the non-adjusted, non-inflation adjusted budget, multiply it by the inflation factor. Back at the data, now I have budget, non-adjusted and adjusted, U.S. box office non-adjusted and adjusted. Just for kicks to review why this matters, let's go ahead and take the non-adjusted data, U.S. box office and budget. Because one of the questions, of course, with movies, maybe you don't know this, is that if I spend more to make the movie, will the movie make more money? And there is your scatter plot. Kind of looks like it. It's not perfect. It looks curved, perhaps, but it does look like, I'm going to flip these, by the way. There we go. If budget, now some of these, bunch of cheaper movies made all kinds of money, but up this way, you know, if you look at Avatar, Titanic, The Dark Knight, some of these Spider-Man, these made a lot of money, but you spent a lot to make them. So you could use this as an argument when you go into your bosses in Hollywood and say, you got to give me a big budget for my movie so I'll make you a lot of money back. But there's a real interesting data problem here. am I really mapping the relationship between budget and income, or budget and revenue? Because if you look at the data, these range from 1939 into the 2000s. So let's take those back out. Oops. I'll leave title there. And instead, let's look at the inflation adjusted. And again, I want to flip these because I want to let budget predict box office. Now what do you think? How's the relationship look? If I take this to my boss and say, you need to give me a lot of money to make the movie because according to this data, you'll make a lot of money back, it doesn't show up anymore. The original graph was not actually graphing the relationship between budget and revenue. It was graphing inflation. Over time, movies got more expensive to make, and they made more money. If you inflation adjust them, there's very little relationship, if any, between the budget for the movie and the revenue from the movie. Here's a little brain teaser for you to ponder. You'll have to ask me about it in class if you can't figure it out.